Now that we know a little bit about ratio and rates, I want to talk about proportions. And a proportion is just two ratios or rates that are the same. So we've talked about that already. If you have a 2 to 3 ratio, we know that we can get other equivalent ratios by multiplying the terms by some number other than 0. So for example, if I multiplied the terms of this ratio by 3, that would give me 6 to 9. I know that these two ratios are equal. And that's what a proportion is, two ratios which are equal. I could write other proportional relationships by taking 2 to 3 and multiplying by a different number. If I multiply the terms by 10, I get 20 to 30. That ratio is the same as 2 to 3. Because remember, a proportional relationship is just one in which one quantity is related to another by some constant multiplier. When you're dealing with ratio and rates, you often need to decide whether you have a proportional relationship or not. So here's a simple example. Is a ratio of 2 to 5, which I could write like this, the same as a ratio of 4 to 10? And probably the most obvious way to decide that is to look at what I multiply the numerator by and the denominator by. And since that's the same number, I definitely have a proportion. But there are other ways to decide. Another way is that if I were to decimalize this fraction, I would get 0.4, and decimalize this fraction, I get 0.4. Since I get the same decimal, that's another way to know that I'm dealing here with a proportional relationship. But there is a third way of deciding whether two ratios are equal or not, and that is by looking at their cross products. If I look at 5 times 4, I get 20. I will notice that that's the same as 2 times 10. If you take the cross products and they are equal, that tells you that you are dealing with a proportional relationship. Now you might wonder, well, why is that the case? So let me try to explain to you why that's true. If I go back to my statement, which I know is true, if I multiply both sides of this by 5 times 10, which is 50, I'm multiplying both sides, so I'm keeping it in balance. I'm allowed to do that. If I were then to take my numbers, which are, remember, just fractions, and multiply, I can cross-reduce. And you'll notice that what I end up with on the left is 10 times 2, which is what this cross product was. And on the right side, 4 times 5, which is what the other cross product was. So if two ratios are equal, it means that the cross product, in this case A times D, will equal this cross product B times C. And this is a very handy method for determining proportional relationships and solving problems involving proportions. Let me show you how we could utilize that. We have a ratio here, 3 to 8 equals something to 32. We're told it's a proportion because we're given that they are equal to each other. To work with this, I'm going to convert this ratio into fraction form. So this is 3 to 8 is equal to x to 32. Now, one way to figure out what x would have to be would simply be to use what we know from the past. If we multiply this by 4, we can see that that's obviously what we have to multiply by. We would have to do the same on the top if we're dealing with a ratio, and so x would equal 12. But another way I could solve that is using the cross multiplication method that I just showed you. So if we go back to 3 over 8 equals x to 32, because we're dealing with a proportional relationship, it means that this cross product, 3 times 32, must equal 8 times x. And so I have 32 times 3, which is 96. That would have to equal 8 times x. And if I divide by 8, sure enough, I do get x equals 12. So the cross multiplication method is a convenient way to figure out missing numbers in a proportion if it's not obvious what you're multiplying numerator and denominator by in your question. Let's take a look at some problems involving proportional relationships. At the cafeteria, we're told that the ratio of liters of chocolate milk to plain milk, so the order matters, remember, with ratios. Chocolate to plain is 4 to 7. So 4 liters of chocolate for every 7 liters of plain is sold. At this rate, which is telling us that this is a proportional relationship, how many liters of plain will be sold if 100 liters of chocolate are sold? So the 100 of chocolate is known, and we're putting our chocolate stuff on the top, so the 100 goes there, and what we don't know is what x is. And so we've set up our proportion that we need to find the missing term for, and we can go ahead and solve this. One way to solve it would be to notice that that's multiplied by 25, so we'd have to multiply by 25 going that way. You could certainly solve it that way. We could also use our cross multiplication method. We know that this cross product, 700, would have to equal this cross product, which is 4x. And then if we divide by 4, we get 175. So we have 175 liters of plain milk for 100 liters of chocolate that is sold, assuming the ratio stays the same, which we're told it does at this rate. Here's another question. The number of students in a class is in a ratio of 3 boys to 4 girls. And we're told that there are 21 students in the class. How many boys and how many girls are there? All right, now you'll notice that this question is a little bit different than the last one in that we're comparing 3 things. We have the boys to the girls, but then we also have a reference to a total. Okay. Now, if we had 3 boys and 4 girls, that could potentially be a total. I'm just going to put total here of 7. But since we actually have 21, and we're told the ratio is the same, we can see that we need to adjust these numbers through our multiplying factor, which I can see is multiplying by 3. So I can certainly work the question out this way. If we multiply by 3, this would be 12 girls. This would be 9 boys. And that would answer the question. If you wanted to use a proportion to solve this, then what you would have to do is, let's suppose we were trying to find the missing number of x. We would have to pick 2 of the 3 things in order to work with our proportion. So we could work with boys to total, and we could say 3 boys for a total of 7 would equal x boys out of a total of 21. And we could then solve our proportion, which we can see is multiplied by 3, multiplied by 3, and we would get 9 boys. We would then have to do a similar thing for the girls. Here's one more question to consider. If we have 6 fishing lures costing $4.32, what would be the cost of 13? All right, this is a proportional relationship because cost will increase at the same rate as lures. So if we decide to put the dollars on the top, $4.32 for 6, the question is how much money for 13? That would be one way to set up this problem. You could also work out the unit cost for one lure and then use that to get 13. But let's just work with it the way we have it. It's not obvious what we multiply to go from 6 to 13. So I'm going to use the cross multiplication method. 432 times 13. That's going to equal 5616. And that's going to equal the other cross product, 6 times x. We would then divide both sides by 6. So we take our answer and divide by 6, and we will get a cost of $9.36. Statement answer, it's $9.36 for 13 lures.